Hola, mi clase. All right, we're doing 6.1 part 2. So we're going to learn the rest of the exponent properties. So today we have a power of a power. It's when an exponent is raised to another exponent. And so we will multiply those exponents. So it'll look something like this. 3 raised to the second. And then we'll take that and raise it to the third. So we would then do 3 raised to the second times 3, and we would get 3 raised to the sixth. Quotient of powers is when I'm dividing two terms with the same base. I'm going to just subtract those exponents. So, we'll have 4 to the 7th, and we'll divide it by 4 to the 5th. If these, since they're the same base, I can then just take these exponents and subtract them. So I'll go 4 raised to the 7th minus 5, that's minus, okay, equals 4 to the second. 4 to the second is pretty simple, so I'm actually going to even reduce or simplify that all the way down to 4 or 16. All right, when it's really big ones, we probably won't ask you to do them, but when they're smaller ones, oh, sorry. I don't know what I just clicked. Sorry about that. When they're smaller ones, we will probably not. Smaller ones, we'll probably simplify them. Alrighty, so this is a version of a power raised to a power property. So it says, what is the solution of 27 raised to the x minus 4 equal to 2x raised to the 2x minus 6? Okay, so these are our exponents. Right now, they are not the same base, so I can't actually even compare anything. So what I'm going to have to do is I'm going to break down 27, and I'm going to make it so that it's the same base as this one. So 27 is the same as 3 raised to the third power, okay? Because 3 times 3 times 3 would get me 27. So what I'm going to do is change this to 3 to the third, and then I'm going to raise it to x minus 4. Now, if you notice, I have a power raised to a power. So this is the same as 3 to the third times x minus 4. And then I'm going to have that equal to 3 to the raised to the 2x minus 6, right? So that I got that from right here. So now, just like our last note takers, since I have the same base, since these are the same base and they're saying they're equal, this exponent has to be the same as this exponent. So I'm going to go 3 times x minus 4. I'm going to set it equal to 2x minus 6. So now we have an equation. We would distribute 3x minus 12 equals 2x minus 6. I like to move my variables first. So x minus 12 equals negative 6. I don't want to lose that negative. I'm going to add 12 to both sides, and I get that x equals positive 6. All right, so this is very, very similar. I don't know why that is on there. It's really bothering me. Hold on. It's probably because of this. There we go. So again, these are not bases that are equal to each other. And so I want to first get them in similar bases. This one we actually did yesterday, right? 1 over 125. We found out that 125 was the same as 5 to the third power. Remember that? And then what I want is maybe have a similar base here. So I'm going to change 1 over 25, and I'm going to change it to 1 over 5 to the second. So now you can see that they're both raised to the fifth power. Another thing we saw in our quiz yesterday is negative exponents. So negative exponents cause this to flip over. So I'm going to change this to 5 to the negative 3. So all it is that when I take, it's a reciprocal. So I'm going to just flip it, and that's where the negative comes in. Anytime you flip an exponent using an exponent, it's just the negative. It doesn't make the number negative, it just makes the reciprocal happen. So Same thing here. I'm going to get this into the numerator and I'm going to make it -2. So now that I have common bases, I'm going to then have all of this with this common base. So I'm going to have 5 to the -3, that's the stuff inside the parentheses, raised to the -x over 2. And that's now equal to 5 to the -2 raised to the -x minus 3 minus 2. So product, or power raised to a power, I multiply. So this is the same as 5 raised to the -3 times -x over 2 equals 5 to the -2 times -x over 3 minus 2. All right, so now I have these common bases. So since 5 to all of this is equal to 5 raised to all of this, these are now equal. Okay, so I'm going to kind of go like this. Oops, that was not a very straight line. -3 times x over 2 equals -2 times -x over 3 minus 2. So I'm going to just multiply here, right? If I have numerator, it's going to become negative. Oh, I lost my negative here. Oh, hold on. A negative times a negative is a positive, right? -3 times -x is 3x divided by 2 equals negative times a negative is a positive, so 2x over 3, and then -2 times -2 is positive 4. So I'm actually going to multiply everything by 6, get rid of that denominator, if you remember that from equations. So 6 times 3 is 18. 18 divided by 2 is 9. See, now my denominator is gone. 6 times 2 is 12. 12 divided by 3 is 4. And 6 times 4 is 24. So I'm going to subtract my 4x. I get 5x equals 24. Divide by 5. And x equals 24 over 5. There we go. Alrighty, so for this one, why don't you see if you can figure out what base I would need to do 4. All right, so 4 times 4 times 4, how many times would I get 256? So I want you to pause and try to figure out what that would be. So 256 is the same as 4 to the 4th power. And so then I would just change that and get x plus 2. But I'm going to use my power of powers, so I'm going to go 4 raised to 4 times x plus 2. And now that that's cleaned up, I can set it equal to here. All right, this might be also another really good time to pause, see if you can solve it, and see if you can solve for x without me. So I would go 4 parentheses x plus 2 equals 3x plus 9, 4x plus 8 equals 3x plus 9, so minus 3x, x plus 8 equals 9, minus 8, and x equals 1. All right. So this is quotient of powers. It is similar, but we need to subtract our exponents. If you also notice, we have a power raised to a power. And then we also have this, where this is, it doesn't have an exponent. So anytime it doesn't have an exponent, we can just put a 1 on it, because there's at least 1, right? So since there is 1 there, it's just itself, you know, on its own. So this is raised to the first power. So we need to first apply this power of power property, which is to multiply. So it'll become 2 1/3 x divided by 2 to the 1/3 equals 2 to the first power. Quotient of powers say I subtract. So this is going to become 2 to the 1/3 x minus 1/3, and then that will be equal to 2 to the first power. Now we have common bases. I know that this has to equal this, so I'm going to go 1/3 x minus 1/3 is going to equal 1. I really want to get rid of these fractions, so I'm going to times by 3. So this becomes x, this becomes 1, and this equals 3. And then I'm just going to add 1, and I'm going to get x equals 4. So it probably looked a little concerning because of all these fractions, but if you notice, once you remove the fraction, it becomes pretty simple. Alrighty, we don't have to use product powers, we're just going to use quotient of powers. So it says, since these are the same bases, I'm going to subtract. So it's going to become 3 raised to the 3x over 4 minus 1/4, and that's going to equal 3 to the negative 3/4. So now they have common bases, so I'm just going to set these equal to each other. 3x over 4 minus 1/4 equals negative 3/4. All right, why don't you try to finish that up? Pause, finish that up, and we'll see if we got the same answer. So I'm going to times by 4. Get rid of these fractions. So 12 divided by 4 is 3x. This becomes 1, and this becomes negative 3. So I'm going to add 1. I get 3x equals negative 2. Divide by 3. We should have gotten x equals negative 2/3. All right, so things to remember. We had our quotient of powers and our power. So power is like a to the b raised to the c. It's a really bad c. Would be a to the b times c, which we also can write as a, b, c, like this. And then we had quotient of powers, so that's like a raised to the b over a raised to the c would be the same as a, b minus c. All right, so here is your independent practice. It's similar to the first couple where you're going to have to change the 16 so it matches this base. All right, until next time, adios.